So good day everyone. So you're welcome to my online class. So where I'll be discussing physics calculation. So last class discussed derivation of equation of motion, how you can derive these equations. So that means we derived these equations in our last class. So what are those equations? V is equal to u plus at, that is equation 1. So equation 2, s is equal to ut plus half at square. Equation 3, s is equal to u plus v over 2 on the bracket t, and v squared is equal to u squared plus 2s. So we derived these equations in our previous class. So today we are going to look at how we are going to use the equation to solve problems. Now, let's look at it. There are tips. There are tips that we need when we are solving this kind of question. When we are solving our equation of motion, we have tips that will enable us to solve the question effectively. So what are those tips? So number one, tip number one, when an object moves or accelerates from rest, its initial velocity u is equal to 0. So that is tip number one. That is when an object accelerates from rest. So that means u is equal to 0. Tip number two, when a body comes to rest, that is when a body is on motion, come to rest, its final velocity v is equal to what? 0. That is tip number two. Tip number three, when a body velocity is constant, that is there is no acceleration, that the body is not accelerating, that means velocity remains constant, so therefore acceleration a is equal to what? 0. So that is these tips will be used to solve questions. Now let's apply these tips to solve questions. So let's apply it to solve what? To solve questions. Look at this. It said a particle accelerates uniformly from rest. Don't forget the tips given above. It says when an object accelerates from rest. So therefore, so let me say solution. Solution. So given, what are we given? Given that, so we said when an object accelerates from rest, that means u, initial velocity u is equal to what? 0 meter per second. Okay. What is again? Uh, acceleration from at 6.0 meter per second square. That means a is equal to what? 6.0 meter per second square. Per second square. So that is this. So what else again? Said time at for 8 seconds. So that means our time t is equal to what? TMS right here is equal to what? 8 seconds. So what are we also find? And then decelerate uniformly to what? To rest in the next 5 seconds. Determine the magnitude of the what? Of the deceleration. We should know that what? It said accelerate. That means when a body accelerates, that means it has what? It has attained our velocity. So therefore, we need to calculate the velocity it attained when it's accelerated. So that means we are looking for what? V first. Is that clear? So we calculate what? V first. So how do we calculate V? Look at the formula given to us. The first one, V is equal to U plus AT. Here we have what U, we have what A, we have what C, we have V. If you look at this formula, we can see that what this parameter given here, U, we can find it here, V, we can find it here, A, we can find it here. Everything can be, we can find it in equation 1. So that means equation 1, you can use equation 1 to solve this particular what question. So therefore, V is equal to what? U plus AT. So therefore, what are U? U is what? Is 0. Plus, what's our A? A is 6.0 meter per second square. So we have what? 6 times. What's our T? T is what? Seconds. 8. 8 seconds. So that means 6 times 8. We have what? 48. The unit of velocity is what? Meter per second. So that means we have solved the first part of the journey. So we have solved, we're able to get the velocity after 8 seconds. So we get the velocity after what? 8 seconds. So now, and then decelerate. Take note, we said when an object decelerates, another name for deceleration is what? Is retardation. When an object decelerations, can you see? So the second part of the journey, when an object what? Deceleration, that means uh when it decelerates, what happens? Let's see, and then decelerate uniformly. Can we see? To rest. So when it decelerates, we know that what? V is equal to what? 0 meter per second. So if it accelerates from rest, U is equal to what? 0. But when object decelerate and come to rest, exactly now, it's already in motion, then it now come to rest. So therefore, what will be 0? V is equal to what? 0. So take note of that. So therefore, when you say and rest in the next 5 seconds. So time for this particular one is what? Is 5 seconds. So therefore, determine the what? Deceleration. So in this case, we are looking for what? Minus A. So that is what we are looking for. That is negative what? Deceleration means negative acceleration. That is what we are looking for. So how do we calculate this? How do we calculate this? So we are still using the same formula, which is equal to what? V is equal to what? U plus AT. So what's our V? V is what? 0. So what's our U? U will becomes what? 48 meter per seconds. So that means the velocity we get there will now becomes what? Its initial velocity. So therefore, we are not going to have what? 48 plus what's our acceleration? That means that is what we are looking for. We are looking for A, right? That is negative A. We are looking for A. Then what is our given? T. What's our time? Time T is what? Is 5. So 5. So therefore, if this one comes a minus 48, is equal to what? 5 what? 5A. Can we see? Minus 48 is equal to what? 5A. So therefore, we are looking for what? A. Divided by what? 5. By 5. So what do we get next? This cancel this. So therefore, A is equal to what? Minus 48 over what? Over 5. And that will give us what? I think 9.6 meter per second square. Minus 9.6 meter per second square. Or we can say minus A is equal to what? 9.6 meter per second square. So minus A means what? Retardation or deceleration. Take note of that. So we have solved that. So now let's move to the next question. Let's move to this question. A body accelerates uniformly from rest. Don't forget, when a body accelerates from rest, so what will be 0? U will be equal to 0. At the rate of 3 meter per second square, so that means A is 3 meter per second square. For 8 seconds, the time is what? 8 seconds. Calculate the distance covered. S is unknown. Calculate the distance covered. Don't forget the formula we given. So look at this formula. If you look at this one, V is equal to U plus AT. We are looking for distance this time, so there is no distance here. S is equal to UT plus half AT square. We have S. We have X. We are looking for X. We have U here. Can we see? Then we have T. So therefore, we can use this formula. We cannot use this one S is here too, but we are not given the velocity. So therefore, the suitable formula to use in solving this is what? S is equal to what? UT plus half AT square. So therefore, X is equal to what? What's our U? U is what? 0 times time. What's our time? Time is what? 8 plus 1 over 2 times what's our A? A is what? Is 3 times 3. Then what's our T again? In this case, T is having what? Square. 8 square. You can see? So that means 0 times 8 0 plus 1 over 2 times 3 times 64. You can get that. A square means what? A square means 8 times 8, 64. So therefore, we are going to say 2 in 6, we have what? 3, 2 in 4, we have what? 2. So we now have what? 3 times 32. So therefore, we are going to have what? 3 times 2, we have 6. 3 times 3, we have what? 9. So the answer is what? 96 meter. We look for the what? Distance. S is equal to what? 96 meter. I hope that is clear. So next questions. With the next question, watch the next video to get the next question. So thank you.